Hello, Internet, and I hope all of you are enjoying the KubeCon Amsterdam. And today we are doing a Paralus office hour just to let you know some of the recent updates around Paralus and some of the very good news that we have to share today. But meanwhile, let me go straight to one of our core maintainer and one of a friend of mine from Infracloud Technologies, Atul Priya Sharma, and he's also been announced as a CNCF ambassador. And today we will figure out how to secure, how to give you a AWS marketplace overview, and plus a guided and practical challenges associated with implementing Kubernetes RBAC manually. Once again, Atul, how are you? And thank you being on the Paralus officer. Are you enjoying KubeCon?
Hey, Sam. Hey, everyone. Thanks for having me here. Absolutely. I mean, even though I am not attending KubeCon in person, but then I think even virtually, a lot of buzz is being generated by folks, especially in the CNCF Slack and everywhere else. I think we are, we are having a good time, I would say.
Yes, absolutely, absolutely. I think this time the great news is that we're missing very big time because now we have a parallel booth. Previously, we do some virtual calls on the KubeCon side, but now we have a parallel booth that we're
Right.
missing big time. There are some wonderful, but there are maintainers out there, so you can join them, ask question around that, and feel free to share GitHub in issues if you're able to figure out those issues as well. So without further delay, let's me start sharing my screen. Have we prepared some of the slide to walk you through of some of the steps we're talking about. So let me start sharing my screen today, and I hope this will be visible to you. And Atul, will you let me know if you're able to see it? Yes, I hope you can guys see my screen now. Atul, do you see the screen?
Yes.
Okay, thank you, thank you. So let's go. Who I am? My name is Saim Safdur, working as a developer relations manager at Rafay System, and Atul is working as a senior developer advocate at Infra Technologies. And this is
You can put it to
159 project.
presentation mode, Sam. You can just put it to presentation mode. Yes.
Yes, absolutely. So is it still able to see it?
Perfect. Yes.
Okay, wonderful. So if you look at the CNCF landscape, we have more than 159 projects, including in this landscape. And this is a screenshot today from one of the keynote from the KubeCon. And can you spot Parallels? Because it's just not a year old project. It's going to be, I think, nine-ish or 10th old. We did have a good start, but we're able to figure out this project to be listed in the digital ocean marketplace and also in the AWS marketplace. So that's the big news for the very small project. So there are a number of projects I have contributed, and Atul has done a wonderful job in doing some blog posts on various technologies on one of his website, and some of the articles available on the CNCF. So that's landscape is huge. That's why this conference being held to help you educate around which project to use and where to find the community if you're able to find problem while working with these open source technologies. So now we are the Paralus community. So if you work on the Paralus, you can talk to me and Atul on the Twitter, on the Slack channel, and we help you figure out how you can start using this project and without having any problem while working with it. So
I
one of
think,
the recent,
can we go back
yes,
to the
Atul, go
previous
ahead.
slide?
Yes,
I, I
sure.
noted I noted one thing really uncanny over here, which is very good. So if you see the photo of the Parallels booth, there are a couple of people standing, and in fact, the person in the green jacket is having the same color that is of the Parallels logo. So that's a
Yes.
great thing. I mean, that person should be awarded for coming in that colored T-shirt for visiting our booth.
Yes, absolutely. That's a great pointer. I definitely I'll ask my team to give some shirt or swag to him after we disconnect on the call. That's a great call out, Atul. So let's go. And this is a booth called K7. There's a other all of the open source project has a booth in the KubeCon. dedicated to talks around open source projects. So we are near to the VASM, and that is K31, and we are in the front of that VASM booth at the K7. So make sure if you are there, join us and give some journey about how you are accessing Kubernetes cluster remotely. So one of the previous KubeCon talks, we talk about why is securing access to Kubernetes is important. And one of the shadow servers report has give us a huge number and a very alarming number. There are 380,000 open Kubernetes API server. 84% of Kubernetes cluster were accessible via the internet, and 53% in the United States. And these numbers are huge, and we need to solve those challenges. So one of the talks we did on the KubeCon Detroit is help you figure out how you can access or secure remote cluster anywhere by using Paralus, and that listed on the CNCF website under Cloud Native Security Con, and you can check those out as well. And one of the those talk is available on my YouTube channel that's called Cloud Native Podcast. You can search on the internet, on the YouTube, and you can watch those sessions. But today is our focus is little different. We're talking about today the role-based access control and how it's challenging and how it's implementing. It's the biggest challenge for the people who are using it. So let's get the stage here first. So we know that the developer are often forced to work on repetitive things where whenever they start developing a new service or an application, those repetitive tasks may include creating a boilerplate code template for a new service that already exists, setting up a test bed, spinning up dev test environment. That is the repetitive task for the developers. But the platform has their own and the platform teams has the same task. They give back access to securing clusters. They give you access to the namespace. They give access to the services running in the cluster, and they give access permission who can access the who can access this service, who can access that service. All those tasks is repetitive, and that's platform teams able to solve how they can do it. But if your Kubernetes journey just started with a handful of team members and a small cluster consists of only few nodes, you might not have a systematic approach to authorization yet. Perhaps you even granted everyone on your team a cluster admin permissions to keep management simple. But remember, we all know not every developer within the team needs unrestricted ability to create, modify, and delete resources. And if there is unrestricted access, 90% of the time you are battling with troubleshooting tool to learn who does what and when. And as the number of cluster nodes, application, and team member increases, you will want to limit the resources your team members and application can access, as well as the action they can take. The role based access control framework in Kubernetes allows you to do just that. For example, it can help you ensure that developers only deploy certain apps to a given namespace, or that your infrastructure management teams have a view only access for monitoring tasks. That's where your platform teams work on the repetitive task, including setting up a RBAC, revoking permissions, pre-configuring role across clusters, namespace projects, and more. In Kubernetes, RBAC has in Kubernetes, we have cluster roles and roles that define action a user can perform within a cluster or namespace, respectively. You can assign these roles to a Kubernetes subject, user, group, or service account. With role binding and cluster roles, cluster admin, this is a super user can perform any action, any resource in a cluster. Admin, this role permits unlimited read write access to resources within the namespace. Edit, this role grants read write access within the Kubernetes namespace. A view role, this role allows read only access within a given namespace. So, practical challenges to Kubernetes role based access control. So we can understand like there's this concepts called role binding, role, cluster role binding, cluster role. In Kubernetes, we have a cluster wide scope resources and a namespace scopes resources. For the cluster wide scope resources, we use cluster role binding and cluster roles. And for the namespace resources, we use role and role binding. Basically, what you do is you let's figure out, let's say Sime as a user in Kubernetes has a role called view view namespace, let's say red namespace. Then I bind this role to this particular user. So in future, anyone can able to view resources. It can bind to the role that already exists in the cluster. So we won't create more and more namespaces. So that's how RBAC works in a nutshell works. But manual process is well fall apart. We all know. We have hundreds of developers and operation work from the different geography, and we have not just 10 but 100 of cluster. For those cluster, it's very painstaking if we can do this step manually. So, so basically for the RBAC scenario, we have staging, dev environment, and let's say we have an operation team that has these domains, and we have an app namespace can access or Mango namespace can access. But now let's figure it out the architecture behind how the RBAC works. So the manual configuration of role, Kubernetes does not offer native tool to facilitate automatic granting of roles or updating the role bindings. Visibility into user access, Kubernetes offers no built in tools for easily identifying which level of access a user has within a cluster. Then comes the concept called visibility into cluster configuration. Kubernetes also lacks functionality to help you manage your complex RBAC configuration. It's up to you to keep track of your roles, role binding, cluster role binding, service accounts, groups, tokens stored as secret, and what else you have configured. So there are two approaches to go about the challenges of Kubernetes RBAC implementing. First is a manual approach. And what does the manual approach look like? Let me share a small video on that front with you so you can able to understand how, how this manual process will look like in the practice.
So I think by the time Sam is getting the video in place, he did give a very nice overview around the RBAC process that Kubernetes has. So you essentially have a role, you have a cluster role, you create a role binding, add a user permission, and then that's it. So I think this video shows really well, what are the clear steps that you need to follow to enable access to your cluster using the traditional RBAC that Kubernetes provides. And it might sound really simple. In fact, it is simple. I mean, once you'll see this video, you'll see what we are doing. The process that we follow, the way we try to create a role, and then the way we create role binding and so on.
Yes, absolutely. So basically, I think if you look at the first we need to create roles for user per user type. So there is a resource called in Kubernetes role. We can name it, let's say, read only. We can access which namespace these roles belongs to. We can call it default. What are the API groups? Let's say we have deployment, replica set, or service account, replica set, daemons, or cron jobs, everything that belong to the API groups. Then what the verb we actually works on this case, we can say like on the verb, let's say on this namespace, we have a role called this. In that namespace, we have a kind of a get role, and you can actually view this role. And and you can list, watch, view, update, all these kind of stuff. So that is the first step. You first create a role that associate with the, and for that you can create a service account for that. And
Yes. So in fact,
uh,
yeah. So in fact, what you see here in the video is where we start by creating a service account. So we created a namespace called test, which you see there. Then we create a service account, and then we just we did a regular kubectl apply f with the service account YAML, and you see that the service account called foo is created at the moment, and we saw the metadata that was a part of this. Uh, so let's wait for the video. Maybe Sam, do you want to turn down the video quality if it is, you know, I mean, on the settings you can see if you want to reduce the
yes, Atul, I
quality
will
of the
try to
video.
see. Yes,
Yeah, we can
absolutely. Let
probably
me
bring it
go to
down.
the twist.
Yeah,
Yes, I hope. Yes, now
perfect. So if you see now, what we have done is we
check.
first created a yeah.
Yes, go ahead.
Sure, sure, sure. So now if you see kubectl comes with an auth verb, which is basically kubectl auth can I. And we just try to check that using the service account that we just created, are we able to get pods in the namespace called test? So if you see at the moment, it shows no, which means that we just created a service account and we don't have access. So what we do now is we create a role, and in that you see the metadata that we have given. So you see that the namespace is test. We are creating a name as test admin, that's the username, and then we are defining the rules over here. So we have API groups, which is what all API groups can we access. We had verbs and we had the resources. So the moment I apply this role, what you will see here is that this particular role is created, and now when I try to check, it still gives me the result as no. Now why this is happening is that even though we have a service account in place, we have a role in place, we need to create a role binding which basically connects your role with the actual user. So if you see here, that is what we are doing. We are linking the service account, we are adding the role, and we are just creating the role binding. And if you saw in the role earlier, we gave access to all the verbs. So we will see now, the moment we do get pods, you see it is yes, because we have given it access to everything. So, even create, deploy, or get. In any case, you see the result is coming as yes. Now, the moment, let's say I change the namespace to something else. Now, the moment I do it, it gives no. Why? Because the role that I had created was specific to a particular namespace. So only we are accessing access to that particular namespace, which was test, which was for all the API groups, for all the verbs. So I was able to do a get pod, I was able to create pods, I was able to deploy, and everything else. And now, if you see here, what we are trying to do is I guess, will be here we are creating a different role reference for this one, basically a new cluster role binding. So the cluster role binding is not specific to a particular namespace. It's a cluster wide role that is created. So the moment I now try to check using this particular role that I've created, you will see that I have access, yes, even to the namespace called Cube System, because this is a cluster wide role that we just created. I change the namespace to default and I still see yes. So it shows that you can create roles at the cluster level as well. So this is a pretty easy process to say. So you first create a service account, then you create a role, you define what all is required, the API groups that access is required, the verbs, the resources. Now, while the process seems simpler to do, the issue arises the moment we move from one cluster. So as long as you're doing it on a single cluster, it's very easy. But the moment that scales up to, let's say, tens of clusters or hundreds of clusters with hundreds of users, then taking this manual approach is really difficult. Right, Sam? Anything you want to add to this?
Yes, absolutely, absolutely. I think the Kubernetes what does is like on the all of the thing, like Kubernetes knows that the everybody we need to find a we need to find something in to give people access, but they haven't implemented it. They give you the RBAC, but you take the responsibility of configuring this up and making sure that you have proper setup in place. Here's the visual appealing of how the Kubernetes RBAC objects and entire things work. So I think if you work in the Kubernetes on daily basis, if you spend a lot of time, Kubernetes have a concept called ingress object. Kubernetes have a concepts called services. Kubernetes has a concepts of called networking. Kubernetes have this concept of called containers runtime. So basically, Kubernetes is actually ready to implement those interfaces. But in Kubernetes, there is a no user object. So it's very challenging to me to give somebody access like sign can do this. How? For that, Kubernetes is actually implementing role-based access control. So this means the Kubernetes RBAC is in there. Number one, you able to find a steep learning curve behind it because it's not very simple. If you work in a 10 and 20 of the cluster and 100 of people working on the same on the team, then you create role first. Let's say you call a role called admin, and then you bind that role to, let's say, Atul. That Atul is now an admin within the cluster, and then you define what are the resources in Kubernetes Atul can view. So you can say like Atul can view deployment, replica set, ingress controller, service meshes, Argo City cluster. These namespaces he can actually view. Let's say there's another role called and is a junior member in the team, and we create a namespace, a role called view deployment. Then you create a role called view deployment, and then you bind this role to, let's say I am a junior member in the team, and I am now bind to this role called view deployment. Now every time I access to now which namespaces I can see deployment, I can access like in orange namespace, Sime as a junior developer within the team can only view the resources and then do not do editing or updating any of the object. So that's a hierarchy is actually come quite of a, there are so many moving pieces in place. Then there is a concept called cluster role binding. We have a namespace scoped element and we have a cluster scoped element. For the cluster role, there are objects in the Kubernetes that a cluster scope. Anybody can access it. For that, namespace won't work. You actually create a cluster role and cluster role binding. Basically, you said this cluster has this role, and then you allow this cluster role binding to actually bind to those objects. So work is different, but that has a concept different. But I think the main challenging associated with implementing RBAC manually is the simplified RBAC strategies reduces the amount of manual effort. Because I think I definitely draw some point here without before we talking about the parallels. Is number one. Let's say today is day 01, and you are actually today is day 01. You install a Kubernetes cluster. You created a namespace, you deploy Argo CD for GitOps, and then you deploy app. Day 02, now I joined the same team in day 02. Now I'm using the existing namespace. Now I start reducing the images sizes. I'm now securing the base images. I'm now installing the scanners, deploying the policy engine, install service mesh. It's too complicated. Use another one. Uninstall the existing service mesh. Oh ho, my app was deleted accidentally. Now, it's now I'm actually deleted the policy engine. Let's enforce policy. The DevOps team now created a namespace. Dev team asked, give me access to this namespace. Let's say, give me access to Argo CD namespace. Access granted. Now you are Argo CD deployed, app deployed. Now in day 03, I need a service mesh. DevOps team, please give me access to infra namespace. Dev. DevOps replied. DevOps team replied, access granted. Now Istio installed. Already app is broken. DevOps team, please create a rule next time. Dev can only view namespaces that belong to me and nothing else. DevOps, what happening to the existing feature? It's broken. Why? A new member joined the team and accidentally broke the Argo CD cluster. Dev team, please create a role that says John can only view resources in this namespace and do nothing else. That's where Kubernetes RBAC come into the picture of giving giving our simplified strategy of implementing RBAC. So the simplified RBAC strategy reduces the amount of manual effort associated with creating individual roles and modifying them whenever the user access need changes. Instead, admins can create and administer a core set of rules and use them to manage the access of multiple users. Unfortunately, this approach won't completely eliminate manual effort. Admin might still need to create custom roles on an individual basis when the generic role binding based on user type do not fit the need of individual user, and you will still lack visibility into your configuration and user permission. Manages are back using third-party tools, and one of those tools is called Paralus. Paralus offered a centralized and automated way to manage Kubernetes RBAC. First, admin configure role and permission within the cluster, and then creation of custom roles, revoking of permission, and dynamic and immediate changing and revoking of permission. Now, how this actually solve within the practical to real world scenario? This is where Atul can help us on the first how actually parallels work on the architecture part. Plus, we will give a demo as well. Now, over to you, Atul, to give us some highlight how this RBAC is actually solved.
Sure. Thanks a lot, Sam. So I think we did a fair bit of understanding around what RBAC is and how it's easier to do in a single cluster, but then the moment it grows up, that's something not easy to manage, and that's where you probably need some sort of tool that can help you make the whole access management process easier. And that's where Paralus comes in. So before I deep dive into what Paralus is, a little bit history on the project, because we have been associated with the project right from the inception, which was somewhere around June of 2021, if I am correct. That's when the whole idea of Paralus started, and we had the teams working on it, figuring out what's the best way or what's the best approach to be taken. And I think within a span of probably 9 or 10 months, Paralus was inducted as a CNCF sandbox project. And I think it's a moment of pride for myself, Sam, and the entire team behind Paralus, the other maintainers who are a part of it, that we were able to sandbox a project in such a short time. And even now as I speak, I can see some issues coming up in the Slack channel. And at one side I do feel that that okay, there are some issues, but then it's a real good sign that people are using your project to their requirements and then sharing their feedback in in an open space. And I think that's what open source is all about. So getting back to Paralus, as Sam already introduced, it's a tool that we have developed. It's an open source tool that we have developed to make access management a lot more easier. So the core capabilities which you see on the screen include creation of custom roles. You can create different users. You can create groups. Even for permissions, you can change it on the fly and revoke them, update them, add them, remove them. And all of this is happening without you actually creating a YAML file or a service account or a role or a role binding. So you essentially, as a user, don't need to do that. And Parallels is something that is what will take care of all these things. So apart from the core feature that we spoke of, giving access, which is zero trust, as we say, and apart from this, we also talk about we also give features like if you have any predefined roles that you have created or you have any namespaces that are predefined in your cluster, that is something also what Parallels can support. Additionally, if your organization or if your team is using any third-party SSO tools, if you are using, let's say, a Google or an Okta or a GitHub for logging in as your identity provider, that can be integrated really well with Parallels as well. So we'll give a very short demo of that as well. Uh, Lastly, we also have a very robust audit logging in place. So whatever actions you perform as a user, whether you are interacting through the kubectl commands or through the UI, all these logs are actually stored. And lastly, Parallels ships as a dashboard and a CLI tool called PCTL. Now, to understand how Parallels actually works, what you see over here is a real high-level overview of how the interaction happens. So you have a request that actually comes in from the user, that can come from a web browser or from the CLI, which actually hits the Parallels core. So talking about Parallels core, there are a couple of major components that are involved, and whatever I'm talking now is available on our website parallels.io. On the documentation, you can go and refer to these as well. So one of the critical components over here is obviously the Parallels core. So internally, we make use of a couple of open source repositories or open source projects. We make use of Kratos, which is used for identity management. We use Casbin, that is used for policy enforcement, and then we also use Sentry, which helps us generate a unique kube config file for every user. Now, apart from the Parallels core, the relay is another component that does something which is the USP of Parallels, if I can say. So one of the good things about Parallels is that you don't need to modify your firewall in order to access your cluster with Parallels. So you just install Parallels on a cluster wherever it is, and you can bring your own cluster. So your existing cluster can reside on your on-prem infrastructure. It can be on a managed Kubernetes service. So it can be present on a Google Cloud, on EKS, AKS, wherever it is. So you can bring your cluster to Parallels without doing any configuration into your firewall, and that's because of the relay module that we have here. So we have a relay server and agent. So agent is something that actually runs on the cluster that you have imported. We will see that in the demo as well, and that is what ensures that there is a uh, seamless interaction between the server and the agent, and that is what ensures that you don't have to do anything with the firewall, and your clusters are just automatically brought into Parallels. And I think once the you have your cluster within Parallels, which this image actually showed, that you can bring in cluster from anywhere. You can then interact with cluster through the CLI, through the dashboard, and the other ways that we provide. So now what we see over here is the demo. Let us just dive into that. So I think that will make much more sense for everyone as to what it is and how it works. So the setting up of Parallels is quite simple and easy. We use the Helm package manager. So unlike all your other open source projects, which you or any other project that you install on your Kubernetes cluster, using Helm, Parallels ships with a Helm chart as well. So that's available, and we have a documentation in place for all the different setups. Sam, can we just pause the video here for a second? The DNS page. Yeah. So we have documentation for all the different setups where you can install Parallels. So you talk about AKS, EKS, GKE, Minikube kind. We have That's the link coming up on your screen. So you can refer there to understand how you can install Parallels to any of these clusters. Now, talking about installation, one thing that Parallels requires is a domain name, and that is because Parallels internally uses domain-based routing. So what you see over here is that once the Parallels installation is complete, you essentially take the IP address that has been assigned to your load balancer, and that is what you need to update as the DNS for your domain name. So what you're seeing on the screen right now is that we are essentially creating three CNAME records of type A, and these are basically star.core connector and star.user along with a wildcard entry. And all these three will be pointing to the IP address of the load balancer. And this is necessary for you to access the Parallels dashboard. So, Sam, we can play this video from here. So that is what you see over here, that I'm adding all these three, and the DNS records are updated for this particular domain. Uh, you can see that the TTL, the time to live, can be left as default, And the moment these are added, all you have to do is head to the domain name that we have, configured with. And initially, it generates a default password for the user as well. So this is the Paralus dashboard that is installed. By default, we have an admin user which is already created, which you can definitely configure in the values.yaml or the in the values.yaml file. The default password is given. You just log in. On the first login, it will ask you to change password, obviously for security reasons. And one of the good things about this password feature that we have here is it actually checks with all the hacked passwords that we have. So if you're trying to use something like 12345 or any hacked password, it will give you an error. So this is the Paralus dashboard, and everything in Paralus is organized into projects. So everything that you do in Paralus is essentially within a project. So we start by creating a project called local project. And within this project, what we'll do is we'll try to import a cluster, which is basically a minikube cluster that is running on an on-prem setup. So all I have to do is hit new cluster and import a new cluster. That's where it will ask me whether I want to import a cluster that is from an edge location or from a cloud. So since in this case it's an on-prem location, I'll choose as edge. And the type of distribution, it will be others because obviously it's on-prem. You give it a name, and that's when it will create the cluster configuration for you. We leave the proxy settings empty for now until unless obviously you have any separate configuration policy HTTP proxies that you want to change. So once you have this, what you see here is it will ask you to download the configuration file, and you essentially need to deploy this file on the cluster that you're planning to import. So in this case, it's the minikube cluster that I'm trying to import. So I'll just apply this file. And what this essentially will do is that it will install the relay agent that I just spoke about, which will create a namespace. It will install all the CRDs, and then it will establish a connection with the Paralus, the relay server present at Paralus. So the moment that happens, you see on your screen that the import is successful. So this is where the communication happened. The configuration was done, and the cluster is successfully imported to Paralus. Now, once you have this, you are able to interact with the cluster like you would do usually as well. So we have a web-based kubectl provided for every cluster that you import. So the moment the cluster is imported, you hit on the kubectl option, and you get a very neat UI with the kubectl, and you can run your commands. So your typical kubectl commands: get pods, get ns. So essentially, anything that you can do through kubectl can be done through this UI as well. Now, this is about importing a cluster, but then I think the major part of Parallels is access management. So let us go and see how we are able to, create and manage access into Parallels, and that's where the whole essence of the project comes in. So what we do now is the first thing that we'll do is we'll go ahead and create. We will start with the SSO. So like I said, we can use Google, GitHub, GitLab, Okta, whatever. So what we'll do here is we'll try to set it up using GitLab. And all you have to do is you need to create a standard OAuth client to wherever, the service that you're using. In this case, it's GitLab. We just give these details and the application is created on GitLab. We will then take the client secret, the key ID and the secret. We'll just add the configuration. So what this configuration essentially does is that it will allow Parallels to configure a GitLab as a login and the IDP provider for Parallels. So once this configuration is done, what you will see the moment you log out, you will see a button which will ask you to log in through GitLab. So you'll see that button coming up on the homepage as well. So now the setup is done. You can see that GitLab is configured. Let us open a new window and we try to go to the Parallels console. And there you see you have a button called sign in using GitLab. All you have to do is just click on it, use your credentials to log into GitLab. The moment you do that, since our OAuth client is already configured on GitLab, it will do the authorization, send back the request to Parallels, and this is where you land. Sam, can you pause this video for a second? Right. So now what happened was the user was successfully authorized and he was redirected back to Parallels. But what you see over here is that he gets an error which says no access. And this is because by default, Parallels will provide every user coming in zero access. So any user who comes in, whether it's a new user that is created through Parallels or if it's a new user that is created or using an IDP, there will be no access given to them. So let us see how we can configure this access in Parallels. Sam, we can move ahead. So what we will do now is we will create a group. We will see the groups that are there. Obviously, we'll first try to see the users over here. So the moment I go to IDP, you see my user, which is present, the GitLab user that was there. But that user is not being assigned to any group or it doesn't have any permission. So what we do is we create a new group, and within the group we will try to assign that particular user. uh, so let us go to add user, and this is where we will add the GitLab user that we just logged in with. And once the user is added, we then have to assign a project to a group. So a group in Parallels can be assigned to a particular project. So what we'll do is, if you remember, we started with a local project that we created. We'll import that. And then on the right of the screen, if you see, these are the various roles that are present. So all you have to do is, uh, choose whether you want a project read only, write, namespace admin. Without doing anything, you just choose the rules and create the particular group. So now if you see, the group is created, we have the user assigned, we have the permissions in place. And now what I have to do is I go back to the window and I just hit refresh. The moment I do this, Parallels now knows that, okay, the new user who logged in through GitLab is now added to a new group which has a project read only permission. So the moment you see here, I have the local project where you can see the cluster that we have imported. Now he can obviously access the kubectl, the web kubectl that we have given. So we can do a kubectl get namespace or anything of that sort. He will be able to, access and run these commands, and it will absolutely work. Now, what we do is, let us try to create a namespace. So let me do that. And if you see, there is an error. And the error basically says that the user isn't authorized to perform that particular action. And why this is happening is because the group that we created and the permission that we assigned was of project read only. And since it is a read only permission, the user cannot we are not giving them access to creating or deleting or modifying any of the resources, and that is where you are getting this error. So if you see, the tool like Parallels makes it very easy for you to manage access at scale for various users, for various clusters, without you dealing with the YAML files. So you essentially, if you compare to what Sam mentioned about RBAC with Parallels, you are not creating a YAML files. You are not dealing with them. So you are not creating a role. You are not creating a role binding. You are not creating a cluster role. You are not creating a service. You are not doing all of this. This everything is done by Parallels for you. All you have to do is just configure Parallels with, let's say, an IDP that you're using, create a project, create the permissions, and that's what it is. And that's the ease that Parallels brings to the table, especially when you're dealing with a lot of multiple clusters that are scattered at different places. Thus making access management a lot more easier. So I guess
Yes,
that gives a good
absolutely.
overview. Over to Simon.
Yeah, yes, absolutely. That's super useful. Every time I see the cool demos of you and the parallels, it's make a lot of sense to me, and I think everybody watching to us why it is so important. I think if I can conclude this conversation and then we go to the biggest announcement, the AWS Marketplace. Before that, I think we conclude this story. Like if you go to the parallels, number one thing is does is like forget about R back on anything. Number one is give you the grouping association between the different projects you have. You don't see in other open source or other places where this kind of architecture or structure exists. Like you log into the cluster and you can see like I have those two cluster, I am a part of it. So that's one major thing that is actually providing to you. Now once you are actually part of those cluster, what should we do? So for that, you actually bring your own GitLab credentials, Azure credential, Google credential, and the credentials you have. Now, if you do this manually, you showed before this, you have to create a role binding, user, service account, painstaking. You can enjoy, you can tell your bosses, oh, I am an expert in RBAC. That's, you've done a super job of implementing it. But remember, if you do it 2, 3 times, your mind is getting stuck and you want to get out of this situation. And that's natural because this happened to me and this happened to everybody else who are watching us. So for that, now if you look at the parallels, give you one thing, you go to the cluster, you have dashboard, a dashboard appears, you have a, you don't repeat cube config file. It's just a one time creation, and then the service account token is deleted, so there is not any security concern associated. I see that. That's one thing. And then you log in and you have an organization of the structures and the cluster. Once you log in, another thing you see RBAC, and the RBAC we configure is very easy. You just create your own IDP, log in. We have already a role assigned, no YAML file, nothing. Yeah, and then you actually see when you log into the dashboard, you can't see anything that is doesn't belong to you. And that's your mind thing. I'm actually not a part of, because now you are working in an environment that is prepared for the security and prepared for the access management from day one. It's not just a tool that give you accessibility, and in day 2, day 3, D4, you actually working on to bring your own access management tool to solve those challenges. That's major puzzle piece that we're actually solving. But I think the quite too interesting to know for our community is getting popular, it's getting recognized, and that's a big achievement for us currently. That is actually process we actually take to register or publish Parallels into the marketplace. Basically, if you, in AWS, if you happen to be a member of AWS partners program, or you want to be your open source project listed to be there, the step one, you register as a seller, because this is an open source project, we won't charge any money. So this is only a $0 product when it's listed in the AWS marketplace. So when you log in as a registered seller, you go to the AWS market management portal, and then you submit product information, and then AWS team reviews it and then publish to limited state, and then you add your container images our case we have 6 7 images regarding creators, Sentry, and bunch of other that Atul spoke about. And we have actually have a conversation around how the Paralus internal common component work way back in March. You can actually watch those conversations on the same YouTube channel as well. And then you integrate with AWS Marketplace API, and then you upload, and then you push the latest images to container images. Then you add your product version, and then you add your user experience version, how the product look like. So actually, let me go straight to the marketplace, how this information actually look like in the marketplace. So I will definitely see more and more people actually trying this out. You can actually search for the Paralus in the search bar, but I've already searched it and landed into the market Paralus. So this gives you the description, like what Paralus actually does. And then there's a highlight. What we feel is actually very, very highly achievable by using the Paralus. Then you go to the Helm chart. Then this show the which version we're actually using. Then this is the latest version of the Helm chart. Now for the users instruction, you can actually log into the AWS console, and you try this command to actually install Parallels into the existing EKS cluster. And then you actually see if these Parallels support or existed. And we are using NY for the ingress controller, that you can see as well. And if you got stuck in any point, you go to this document and you go to the installation part as well. If you're able to find support, you can go to the Rafay website, or you can go to the Paralus Slack channel or the Kubernetes Slack channel for that. But I will encourage anybody who are actually listening to us, please use it and share your experience of how you can actually using our Paralus in the EKS cluster as well. So that's the big news during the KubeCon. We actually figured it out. We are listed in the DigitalOcean. We are listed in the AWS marketplace. Azure is actually in our next plan, but I think we can see the need from the community. They see there's a challenge. there's a RBAC unsolved challenge. It's basically a challenge that actually go to the various different process. I think in the market, in the open source, there's a tool called Kubescape that give you the visualizer how the RBAC works. But I think there's a need right now in the industry can give you the dashboard. You can bring your own IDP, log in into it, and platform engineer can give you, let's say, roles. What role you should belongs to without platform engineers creating the RBAC file, and without developers need to worry about what RBAC file we're actually working on. So that's a big news for us within the community as well. So with that, I will conclude some things about RBAC and RBAC and
Did we lose time? I'm just trying to figure out, and I guess yeah, so I guess we have we have lost Sam. Maybe he would be joining in back. So whatever you saw around the marketplace that Sam discussed, whether it was the AWS marketplace, DigitalOcean, or the Azure that we spoke about, it just makes your lives much more easier to work along with Parallels because you don't actually have to be dealing with installing with Helm charts and everything. You have a one-click installation for most of them. So it makes your lives easier trying out Parallels. And since Sam is gone, he was sharing the deck. So what I'll do is, quickly just to wrap it up. So as Sam mentioned, you can check out our website at parallels.io. You can follow Parallels on Twitter at the rate Parallels underscore. You can start our GitHub repo. That's where a lot of interactions are happening in terms of issues and PRs. And if you're someone who is just starting to contribute to open source, and you could definitely check out our repositories, the Parallels repo, and see if there are any good first issues that you can start with. There are some UI related issues that I'm sure we are looking for contributions. So make sure that if that is something that interests you, go ahead and join the repo, and work with the maintainers to create a PR and get it merged. For any support or to understand more about Parallels, join our Slack channel. The link is given on our website. And lastly, you can follow Atul at the rate tech, the Tech Maharaj on Twitter, and also Siam Cloud Native Boy on Twitter. And feel free to reach out to us in case of any support or issues or feature requests that you might have for Parallels. And I now see Siam joining in, and Siam's there.
thank you. Sorry, brother. That's the advantage of two being two hosted. So your live stream being work as a high availability setup. Thank you, Atul, for the backup. I just lost some connection, but that is actually thank you very much for your time and always inspired by your demo and the way you actually describe this project to the community, how it's feel like. I hope to see more and more interaction coming up in the future for this project. I see it solve a very wonderful challenge and not just our back.
And I guess we lost him again. So yeah, that's the advantage of high availability. So I think that's what Sam was probably trying to add to it, that how easy Parallels makes things to work with access management in Kubernetes. And I would probably wrap it up, and we are close to the 1 hour mark. If you are at KubeCon, make sure to head to the booth K7 and meet our representatives at the booth. See Parallels in action over there, understand from them whatever you want to. Join our Slack community, interact with us, and we would be more than happy to help you. If you're joining in virtually, definitely have a look at this video. Again, come to our Slack channel, interact with both Siam and myself. So that's pretty much it from both of us, Siam and myself, Atul, and we are eagerly looking forward to your feedback, your inputs, as well as your contributions in making Parallels a great open source project. So thank you one and all for joining in. If you are in KubeCon, have a wonderful evening. If you're joining in from everywhere, anywhere else, have a wonderful evening and a wonderful day ahead. So thank you so much and have a great time. Bye bye.